Unit 2 discussion topic, continuous compounding. In this discussion, we'll learn about continuous compounding of interest. Continuous compounding means the number of compounding periods per year is basically infinite. To calculate compound interest, we used a different formula that's shown here. A equals P times E raised to the RT, where A is the accumulated amount, P is the principal, and R is the interest rate, and finally T is time in years. The base E that we see in this formula is called Euler's constant or Euler's number, and it plays a very important role in many applications in math and science. Your calculator may have a base E key. It's usually a second function above the lnx key, or you can approximate E as 2.7183. And I'm going to demonstrate in a minute with a calculator on how to locate that E key on a calculator. So let's say we invest $5,000 for 14 years at 3% interest compounded continuously. So the formula is shown here. So I inserted the $5,000 for the principal. I have my base E raised to the exponent of R. The interest rate is a decimal, 0.03, times the number of years, 14. And we notice here the exponent becomes 0.42 when we simplify. Then I'm going to take the base E and raise it to that exponent, and then finally multiply by the principal, and we come out with a total accumulated amount of $7,609.81. Now I'm going to pull a calculator over and show you how you do it on the scientific calculator. Okay, so in this scientific calculator, I'm going to go ahead and in this one, now you're going to have to figure out on your calculator if you put the exponent in first or if you have to hit that base E key first. This one I put in the exponent first. So I'm going to put in the 0.03 and we're going to multiply by the 14 years. So there's my exponent. Now to get to my base E key, notice I have a second function key here. I'm going to hit that key and notice right down here the E to the X key appears. So I'm going to hit that. And that's going to give me that 1.521961156 that I showed here. And then finally, I'm going to multiply by my principal, which was $5,000. And there I come up with that 7609.81. And actually, it's actually an easier calculation than your compound interest formula. And then just to compare, I went ahead and calculated $5,000 invested at 3% compounded quarterly for 14 years, and that would accumulate $7,597.89, so a little bit less. The continuous compounding yields $11.92 additional over the 14-year period. You can also approximate, as I said on the slide back here. If you don't find that key on your calculator, you can also use for the base E 2.7183, and your answers will come out close enough. So for this assignment, we're going to assume that you have $10,000 to invest, and you get to pick from one of the four investment options shown. Invest 6% for 10 years, invest at 8% for 10 years, invest at 6% for 20 years, invest at 8% for 20 years. And what you're going to do is do the compounding annually, and then you're also going to calculate the continuous compounding and then compare the two amounts. Which one do you think is a better outcome and by how much?